Hashrocket Book Club. I'm here with the usual suspects, and as well as Paul, who did not read the book but is eating a sandwich 2 feet from my face. So, yeah, everybody say hi to Paul, my co-host who hasn't read the book and is not my co-host. Alright, I hope you're all doing well. Whoa, is that really the feed quality? That's crazy.
I don't know.
Oh well. Page 79. Oh my gosh.
It's just Adam.
Someone just ran into the door. Page 79 is where we're going to pick up. That's in chapter 4, the currying section. This will be an interesting place to start just because this particular example is extremely awkward and will start us off on a nice complainy foot, I think. So we're talking about function application. In some purely functional programming languages, a function does not described as being called or invoked, but rather it's implied. So you can't apply a function because functions in JavaScript are actually objects and they have methods. So in this initial example, which is bizarre, and I think the reason he uses the apply method first is because apply is the verb that he's looking to use. It's really strange because you have to pass an array as the second element to apply, because it's technically the arguments array that would show up in the function. In common practice, you're going to not use apply, you're going to use call, and he mentions that at the end of this section. If I had been writing this book, I would have started with call because it's a little clearer, but in any case, the way that he does this, it explains that apply invokes a function, but he doesn't explain why you would invoke a function with apply. And the reason that, and he does apparently address it later, he does address it later in the book in a couple of chapters, but right now he's just using apply to explain currying and partial function application. So it's just really kind of confusing because this example isn't great. When he's in this first code section, he's talking about apply, and so he says say hi.apply and then passes null as the first value. What he's trying to do here is just show you that an apply is a function call, which is fine. There's almost no, probably zero case where you would ever pass null as the first value to apply, and does it fail in strict mode?
Yeah, so if you're using ECMA script 5's strict mode, you can't pass null or undefined like you used to and get the global window object. You'll actually get a type error.
So you're not supposed to use null in this case, and for all the other times that he is deeply aware of what strict mode lets you do and won't let you do, he doesn't mention it here. And it bypasses the whole point of apply, which is that first argument. And what apply and call will allow you to do is change the scope as where the function is being called. In his second example, still doesn't show that. You've got this alien variable, and then the say hi method under that, and then so he says say hi.apply, and then in parentheses alien, and then he's passing the arguments array of humans.
Yeah, and here, I mean, it's good to note that he's taking the code from up above, where he's declaring a variable say hi to a function, and then confusing you by putting a method on the alien object of the same name, say hi, and calling one and then the other in those two statements. And
in this example, he's calling the alien.sayHi method, but what the sayHi method is doing, all that it would have taken to make this as a good example is to console log or something this within sayHi, because what's happening in this situation is that this, when it's called using apply, is going to be the alien. So all this to say that, and he does talk about this in like 30 more pages or something, but he should have talked about it here, is that apply and call allow you to change the context in which a function is operating. Otherwise, I mean, if you just call alien.sayHi, this is going to be the global. It's going to be whatever scope alien is living in.
Alien.sayHi, this is going to refer to the alien object.
Okay.
So he's showing that this in both of those is going to be alien, but he never hits on the fact that they're both going to be alien. He just says, hey, you can do say hi.apply and pass an alien, even though you don't use it for anything in that function.
Okay, is it a mic level thing, guys? I got Hashrocket Chicago in here. Should we move on?
Are we mumbling?
Let's pause it for a second. I'm just going to change some quality settings here. And
Okay.
It's really not
Technical difficulties. Please give us like 20 seconds.
Can you hear us now?
Access live. Alright. Hey, that looks so much better.
Yay!
Alright. Yay. Alright. Are we back? We're back.
Go back.
Yes. This is way better. Alright, we no longer look like a YouTube video from when YouTube launched. Alright, I'm going to go back over a couple of those points again in more brief. Let's see. People actually look like people. Yes, we do look like people usually. Function application. Alright, so what we are trying to explain here is that apply, in this context, he's just using it to show you that you can call a function using it, but what he doesn't explain is that it changes the reference of this. So in the bottom of page 79, with this alien.sayHi, when you say alien.sayHi, he just has it return a string with using the whatever's passed in, which doesn't mention the whole point of apply. If he had just had it return this or some reference to this or explain what this would be in this context, it would really have helped, I think. Because right now, sayHi doesn't need to be under alien or anything, like he's not explaining it. So in this situation, if you call alien.sayHi and sayHi was to return this in that situation would be alien. Now if you call sayHi.apply and then pass it alien, and then pass it your second argument, which is just going to be your arguments array if it's apply, or just a string if it's call, this is still going to be alien, even though you called sayHi without anything before it. Because what it's doing is it's applying the alien context to that function when it calls. I hope that makes sense. So in his initial example where he says hey.apply and passes null as the first argument, not only should you not be doing that, and it's not valid in strict mode, it doesn't address mainly what you would want to use apply or call for, which is to define what this is in the context of the function. So I hope that that covers that section. I just think those examples are don't address the real usage of those functions. And what he's trying to do is lead you into partial application, but I still think that it's a weird way to do it. So we get into partial application on page 80. So you have this is a really nice, simple example of partial application. So you have well, not this page actually, this is the not valid JavaScript thing, which I don't think anyone should be writing a coding book and then putting code and then saying it's not valid. It's just for illustration purposes. You could write valid code for illustration purposes too. So this is an add function. You know, you pass it two things and it returns thing A plus thing B. Yeah. And then there's the substitute one argument, which that's the not valid JavaScript. So the next, let's skip ahead to where it actually starts applying some useful examples. So you've got this partial apply method that's imaginary. And the idea behind this is that you should be able to pass one argument and then apply, call apply, and then pass in the other argument. Still, I mean, if you're still not digging it, that's because it's still kind of weird. These still aren't great examples of how this works. The methods don't behave like this. It isn't what JavaScript does, but he does get a little better at trying to explain when you would want to actually use this and how to actually do it.
But I don't understand why he's going through all the trouble of explaining something that's not in the language.
Well, because partial application can be implemented, but this isn't the way that it's implemented. I think what he's trying to do is show you what partial application does in a simpler way than it actually is done, but I don't think that it is good.
Show of hands, who's ever actually tried doing that in partial application?
Well, that's the elephant in the room, is that it's usually not a thing you have to do.
Now, call on the other hand, I use that all the time.
And that's the thing is, the reason I brought up the point about changing the the this and the first argument of call is because call is totally useful aside from this entire section, especially in DOM manipulation. Sometimes you want to call a function, you want to specify the context in which that function is going to be operating. Maybe you want to call a function that does something to a list, but you don't want to have it be a child of that list. You could just call the function and then pass in that particular DOM element, and then when you're inside that function, you can now trust that this is whatever DOM element that you passed in.
A lot of times I use it in conjunction with like a jQuery click handler, for example. So the function I would pass into it and bind to the click, I don't want to actually invoke the click. So I invoke that function, use call to set the context to the thing that it would be had I just called click.
Yeah, so call is good for manual context setting, which is like, the last couple of pages are just weird. He's trying to explain how functions behave in JavaScript. I mean, it is important to understand that functions are just objects, and so that's what he's trying to get at. I don't know if it's getting you any closer. It reminds me of early calculus, like before you learn integrals, you're learning limits and stuff, and limits don't make any sense, and you get to integrals and you're like, oh, it's the space under a curve. That's something that I can like get my mind around. But for some reason, you have to do all this abstract limit stuff. That's what the last 2 pages felt like to me. It felt like pre-cal. I'm sure that illustration has not made anything any clearer. All right, so here's currying, and he gets simultaneously more and less obtuse in this section, because he decides to use Schonfinkelization as a term, and he actually starts putting that in his code, and it's weird. I'm going to assume it's just for humor's sake. So here's a curried add, and we're going to skip past this long example, because I don't think the long example is a help at all. It's just a messier way of doing it. Skip to the example in the middle of page 82. A curried add accepts parcel lists of arguments. All right, so what this is going to be doing is it's going to look for x and y. If y is undefined, then it's going to return a new function that only accepts y as a value that adds y to x. And then if you get both x and y, then it's going to return the sum of x and y. And so what that means is, and then he doesn't even use it, which is really annoying. You've got to go over to the Schonfinkelized currying example, which is more complicated. But what this would actually look like, this curried add, is you would say add, and then in parentheses you could put 3, and then another set of parentheses you could put 4. And what it would actually do is the 4, that second set of parentheses would call first, it would return a function that would then accept 3 as an argument and add them together. And so you're putting, this is returning half of the function to the second function call, which would then add them together.
Yeah, so
I hope you're understanding that.
he actually, if you look at the example in the middle of page 82 and then look at how he's using it at the top of page 82, then it's a little bit clearer. So you can, you can
oh yeah, there's a good example. Yeah, I'm sorry.
You can store the return function of calling add with one argument as a different variable. So add 2000 is add, and then the first argument is 2000. So we have x stored as 2000, and then when we call add 2000 as a function and pass the value of 10, it gets the variable x, which is currently 2000, adds 10, which is the argument y, and returns 2010.
So yeah, that create and store a new function. So if it's one argument, it returns a function. If it's 2 arguments, it returns a sum.
And really, you can change the add function to just go over the arguments array and return.
Right, and so that's what he gets into is the arguments array. So yeah, and then the shorthand version of that is at the top of page 82, the add 3, 4 is just doing the same thing. The add 4 is returning a function, and then add 3 is the equivalent of the creating and storing a new function. You're just doing it on one line. So here's the general purpose currying function, which is really funny because, again, has anyone here used currying in JavaScript or really any language? If Robert was here, he could probably give an example of actually using currying.
Yeah.
No? Okay.
It'd be a really obscure example.
Yeah, probably really. So general purpose is a bit of a oxymoron when you're talking about currying, but So what it's going to do is continually look through the arguments and then return a new function with that argument and walk through and basically put that stuff together. He has to call, it's still a weird example because he has to call array prototype slice because slice isn't, because arguments array isn't technically a full array and it doesn't have slice on it. Is arguments just an object? What the heck?
Well, I mean, everything's an object. Arguments is an array-like object. So like you've got a property like length on it, but you don't have slice and shift and unshift like you would on a typical array in JavaScript. So yeah, the example that he's got, he's taking the arguments array thing and just popping off the first array position, returning the rest.
Yeah, and so it's just walking through the whole array, creating this like nest of functions that put this stuff together, and then will perform some sort of an operation on each one. So in a practical example on page 83, you have a normal function that just adds x and y, then you Sean Finkelize it and pass it add, and so now you've got this new added function, which is then going to just recursively take, well, yeah, I guess it's more or less recursively take every parameter and just run them all together. And so you can take a single example. It doesn't really matter whether how many arguments are in a particular array or whether they're in the next array or whatever, because Sean Finkelize is just going to walk through all the arguments array and run that, whatever the function is, between each one all the way down until it finishes. So, super practical examples. This is the other problem with currying, is I've literally never read a book with a practical example of currying. It's always stuff like, here's a way that you can add 1 to 4 number 10s, and then you get 41, stuff like that. But those are the examples, so if you want to have a function that adds 6, and then you want to be able to pass it a bunch of different values, that's cool.
Yeah, so rather than just putting +1 at the end of the statement, pass it all in your function.
Yes. So I'm not saying that this is useless. There are totally use cases. I wish I could give you one. I know they exist. There's probably optimization situations in game programming and such where this is really practical, but in the world of web development proper, you just don't come upon it often or ever. But I mean, it helps you. Hopefully, will help you understand how functions work, and seeing that a function can check these two values and either return an operation or it can return another function that then gets called. So you can chain these sets of parentheses together and allow this stuff to walk down. I mean, those are all important principles in understanding how functions behave. So the summary of this whole section is pretty basic. Functions are first-class objects. You can create new ones on the fly, you can return ones, you can attach stuff to them, whatever. They're the only thing in JavaScript that provides local scope, which I really hope you understand by now, and if you're not past that, then you just got really irritated by the last 20 minutes not making any sense. The syntax for creating functions, we talked a little bit about that last week. I don't think there's a whole lot of value there because he's declaring these patterns, and I really am not 100%, we're not super in 100% agreement with them, and other than the fact that a named function is, a function with a name and an anonymous function, his use of expression and declaration is we're saying that's not carved in stone, at least not for us. API patterns are super important. If you weren't listening last week, it's really important to read back through the configuration object sections. Returning functions is a useful thing to understand. Currying, not near as useful as configuration objects and callback patterns. Initialization patterns. I mean, it's the way that he suggests doing it is this immediate object initialization. Is that the rewriting thing? Where was that?
That's where.
Oh no, that's
he's got-
self-defining
He's got
functions.
open
Sorry.
paren,
Yeah.
here's an object, literal, close paren, and then
Yeah.
call function it gets.
So closures, I mean, there's a bunch of different ways to do that, but all your code should always be wrapped in some sort of an initialization function. The performance patterns, memoization is really useful, especially with DOM element stuff. If you're running an each statement, and then within that each statement, you're checking, you're like finding a variable, say that you're running an each statement that's going through every table row, and then you need some sort of a variable that's the same throughout all of those. Maybe you're trying to get the color of the header text or something. So you have this each statement that's walking through header rows, and then if you have a variable within the each statement that's pulling the color from the header text every time, that's an example of computing a value way too many times. You didn't need to do that. Just you should have pulled it once and then had that value in a variable so that you're not hitting the DOM every single time there's a table row in this each statement. So in general, just try to optimize when you're computing values and don't recompute things. And in the world of jQuery and stuff, don't walk through the DOM unless you have to. Self-defining functions, we're blacklisting. You shouldn't really be doing that. Functions that override themselves with different functions is almost always a horrible thing to do, just in terms of other people understanding your code. And that is chapter 4. Thank you for sticking with us. Looks like we have about 25 minutes to jump into chapter 5. I'd like to get about 10 pages in if we can, but we'll see what happens. And this is object creation patterns. So he has this namespace pattern example. The following, his initial what you shouldn't do is pretty good. You've got this variable floating out in the middle of nowhere, a couple of functions, and some objects, and they're not necessarily all related in any conceptual way. What you can do is stick all of this stuff onto a global object. And this is just a good way to namespace your stuff. It helps people read your code. It helps them to understand the context in which a function is supposed to be operating, because the functions, there are ways to do private things in JavaScript, but it might not be readily apparent that a function is supposed to be operating within a particular scope. But you can definitely see now that myapp.parent is it's some sort of a function that has to do with myapp, etc. So it's a readability thing, it's a namespace thing, so you're not overriding functions with different function names. It's just good practice. So the drawbacks are not really drawbacks. A bit more to type is that's not really a drawback if it makes your code a lot more readable. And it's that whole strict optimization thing that he talks about every once in a while. It does technically add up in terms of bits, but that's what minifying is for. Only one global instance means that any part of the code can modify the global instance and the rest of the functionality gets the updated state. Yeah, but your global instances should be wrapped in a function so no one else can mess with them. And also, you should know that you shouldn't be rewriting your global instance. Like that isn't really a drawback, because you could also rewrite functions. I mean, you could rewrite anything. Long nested names mean longer property resolution lookups. Can you imagine when that would start becoming a real measurable problem? You have to be pretty deep. You have to be writing some Java-esque object nightmares.
I mean, if you're writing a complex API, I can see that being an issue. I mean, we had that with a client before, but on modern machines, I don't think it's a big deal.
It's pretty negligible, and I mean there are ways around that, like the memoization from the last chapter, only looking up those properties when you need them and caching them and things like that. None of those are really drawbacks. Those are just things to look out for that mostly would apply anyway, even if you didn't namespace stuff strictly. So here's a general purpose namespace function. So I had something to say about this section. Let's see. All right, so he talks a lot about non-destructive implementations, which is a little bit weird because you shouldn't necessarily have to worry about destroying other namespaces if you're operating in your own environment that you already exist in. This one-liner to check is really nice. The little double bar is really convenient for many uses that don't necessarily have to do with namespaces. It's a nice shortcut that just says set this variable to this unless it's undefined and set it to something else. But this whole namespace redundancy thing that he has on the bottom of page 89 to the top of page 90, this is very like deep level JavaScript. Like I can't imagine that this would actually be useful in a typical like smaller scale plugin context.
Yeah, I mean, if you're writing a library of sorts, then,
Yeah.
like jQuery does the same exact thing. It says, hey, you know, is $sign available? If not, well then you're gonna have to fall back and use jQuery or assign your own version of a global $sign to whatever else, you know, like a double $sign or something like that. But yeah, in most cases, you know, you already know what variable names you use and what you haven't.
Right. Yeah, so and like your stuff shouldn't worry about other global stuff that's out there because your stuff being modified by that because your stuff is always in a function wrapper, right? Right. So, I guess to conclude that section, this namespace, this general purpose namespacing function, don't just cargo cult this and paste it into the bottom of your JavaScript or something. You probably don't need this. There are definitely times when you need to check the existence of a variable in that one line, the var foo equals foo bar, and then a double bar, and then something, double pipe. That's useful. The recursive namespace thing is an interesting example, but you probably don't need it. And if you do,
Then you're using YUI.
then you're using YUI, which he does actually talk about right here, this dependencies business. This is a very, I mean, this is, what do you think about this?
I don't know, there's a JavaScript library, require.js, that does something similar, but it makes a lot more sense than YUI's implementation of it. There's some other one that was brought up internally recently by Robert, unfortunately, because we seem to always rip apart everything about suggest, but the library tried to do something similar and it just didn't work. I don't know, it might be useful if you're writing a large-scale application and you're doing nearly all of it custom, but...
Yeah, if there's stuff that your JavaScript will totally die on if it doesn't exist, and you have to trust that it exists somewhere outside of what you're writing, I mean, then it's it's just good code practice to put that stuff at the top of your excuse me, at the top of your document anyway. So I mean, in the YUI world, you might need a bunch more dependencies. We here at Hashrocket are a fan of not bloating up on jQuery plugins, so we don't usually run into a case where something is dependent on much more than just jQuery itself. In which case, you don't really need a dependency call on that because the $sign's pretty evident in your wrapping stuff. So, I mean, all that to say, if your stuff is dependent on stuff that's not in it, it should say so, and it should declare those variables at the top of the document. That's good practice. The minification example is kind of interesting. At the bottom of page 91, the fact that a lot of the way minification works, and this isn't really even a minification situation. This is also just an optimization. It's the what we were talking about earlier. That if you don't need to walk down myapp every time, or myapp.modules every time, you can just set variable modules, and then each of those you can access off of it. That's good practice. And his example is just showing that that helps with minification. Like, the minification can be like, oh, it's this variable, I got that, and now I can shorten that variable name to this, and then use that everywhere. And you end up with shorter minified code. And really just less redundant code, regardless of whether you're minifying or not. So here's private properties or methods. Nothing attached to an object in JavaScript is technically private. And he's just demonstrating that in a couple of ways. look, if you're attaching it to an object, it's public at the end, whether you're doing it through a constructor function or not, or through a literal, which is probably what you should be doing. So what you do to make private members is just take advantage of function scope in JavaScript. So technically, if on the bottom of page 92, if you're in the function gadget and you declare some variable, it only exists within gadget. So it's not so much private as it is just like scope limited. But practically speaking, if someone is using the gadget function, they can't get to it because it doesn't exist outside of gadget. So it says at the top of page 93, it's easy to achieve privacy in JavaScript. All you need to do is wrap the data you want to keep private in a function and make sure it's local to the function, which means not making it available outside of the function. So it's not technically privacy in terms of there being a special functionality in JavaScript that makes something private. It's just private by virtue of the way scope in JavaScript works. So notion of privileged methods is something as far as I know, he invented for this one paragraph. It's not, I can't remember ever hearing the term privileged method. If a function, if a method that is public access is something that's private within the same object, then that just is probably something it does. I don't know if being privileged is really a term that you need to worry about.
Yeah, I mean, you can, what he's showing is, you know, if you call get name on the new instance of gadget, it has access to the locally scoped name variable within the gadget function, but you can't modify name. So because get name is a property of the return of gadget, it can access whatever was locally scoped. I think he did that in the last chapter. I don't know why he's bringing it up again.
Yeah, I mean, it's just the way that scope works. Calling it a privileged method, I think, is a little bit neither here nor there. All right, so this is super important. In 93, we're talking about privacy failures. The first bullet point is really irrelevant. It has to do with the nuances of eval. But the second bullet point is extremely important, which is that objects and arrays are passed by reference in JavaScript, which he may not have even mentioned until this point. Did he? He might have mentioned it.
Yeah, in Essentials, I think he did.
So what this means is if you have a private member that is an object and you return it, and you, like if you look at this function gadget and there's this object of specs, and you return specs with a public function, you're not returning a copy of it, you're returning a reference to that actual object within gadget, so you just made it public.
So then you can modify screen width and screen height and so on.
Right, you can screw with everything because you're not passing a spec, you're not passing a copy of specs, you're passing the actual object. So there are a number of ways around this. He mentions a couple of them. So let's see. So here's his solution: is don't pass references to objects and arrays you want to keep private. One of the ways to achieve this is to have get specs return a new object containing only some of the data. So you can put together something to return and then return that by assigning variables. Variables are obviously not passed by reference. Excuse me. The principle of least authority, never heard of it. The POLA, which states that you should never give more than needed. It sounds like an awful advice for relationships, but maybe good advice in JavaScript. In this case, if the consumer of gadget is interested in whether the gadget fits a certain box, it needs only the dimensions, so you break it out and you make a get dimensions function that returns a new object with just the width and the height. I mean, that's good practice because now your function is returning something specific, and as well, you're not having to deal with risking passing things by reference. Another approach is to clone the object. He talks about the next chapter is going to have an extend example, which just clones an object. jQuery also has a clone command built in. Is it clone? Is it called extend? Yeah. And that does the same thing, and it also has an option for you to make a deep extend. So I think it'll be a good example to go through the manual extend, but you probably already have one in whatever library you're using. So object literals and privacy. I've got the second example highlighted here, and now I have to figure out why.
Where it returns name?
Yeah. So, oh, and the first example is just less good because he's declaring the variable my object outside of the function wrapper, which is kind of funky, especially when you don't have to. I just liked the second example better as a piece of code. So you have this my object, which is wrapped in a function, so everything within here is private, and it's going to return a getName function that returns the private member. So that way you can call my object.getName, and it's going to give you the name. So you can it basically allows you to make an object literal and then just wrap that within a function call, and that keeps everything within the object private unless you want it to be otherwise. Not super crazy about this whole technique just because this can allow you to end up with a monster return statement. Perhaps there's a number of public functions that you want to create, and so you end up with a return statement that passes an object with like 4 or 5 methods in it.
Yeah, instead you could, at the top of the function scope, you can create a new object and then apply those methods to it, and at the end just return the object.
Yeah, so exactly. And the JavaScript, the good parts, which is a book we did previously in the book club, used that technique a lot, where they'd create a new object called that, which is great. It was good for their example, and all that is a brand new object. You can attach stuff to that and return that at the end of the thing. So in this case, instead of having a monster return statement, create a new object, attach functions to it or methods to it or whatever you want to it, and then return that object. He doesn't talk about it, but we don't like giant return statements. It gets weird when you have this block of code, and the return call is up here, and then all the functionality is below the return call. There's no reason to do it like that. So prototypes and privacy, all he's saying here is that the same privacy rules work for prototypes as they do for the main object. You can have private members that exist within a function scope, but if you attach something to the prototype, it's still public. So this is the revealing module pattern, and this is what we're going to end with. We might actually end a couple minutes early, which is fine. This day has been fraught with technical difficulties and questionable examples. So. This is the revealing module pattern. I don't know what's up with this line, but at the end of the paragraph, he says, enter the revelation pattern, the term coined by Christian Heilman originally as revealing module pattern. So I don't know if the author has decided that this is the new name. It was originally coined as this other name, but check it out, it's called this, or what the deal is. Sounds like someone's chainsawing the outside.
There is construction downstairs.
Yeah. So call it whatever you want. All he's basically talking about is duplicating the functionality of what's inside this and then passing that out. So you have this outside function called myArray. You have all this stuff wrapped in a function, and then you're attaching whatever functions you want to be available outside to the myArray object that's already been defined outside. So at the end of all of these functions, which otherwise wouldn't be visible outside of this function scope, you're copying them into slots into the myArray object. And so what that allows you to do is that if anyone screws with the return function, it doesn't change the definition of the original function within the function block. So that's a pattern that could be really useful to you if you have private functions, and then you want to allow access to them, but you want to make sure that they don't get modified by something outside of it. You just create this object, attach the functions to the object, and then there you go. So, and like he says here at the end of this section, if someone says myArray.indexOf is null, it doesn't matter because myArray.inArray, when you call that, if you look up to bottom of page 96, inArray is going to be
it's going to be the same reference.
Yeah, it's going to be the same reference, sorry.
So you're deleting the reference on indexOf to the original indexOf function, but inArray has the same reference.
Mm-hmm.
But this still doesn't prevent you from overwriting both of them and never having a reference to indexOf again.
Well, that's why you keep the third one.
Yeah. So you have like a triple underscore prepended index, so it's super private. Yeah.
I guess what's good to remember in this section is that he's just trying to give you a bunch of different ways to kind of do the same things. Like, it's a bunch of different ways to create an object, return an object, prevent people from screwing with your code, modularize object creation and methods. Practically speaking, I mean, we're kind of a fan, or I speak for myself, I'm kind of a fan of the just creating a new object and then returning that with whatever methods need to be attached to it. That's pretty much the most straightforward way to do it. None of the rest of these are particularly invalid, but I mean, the book is called JavaScript Patterns. It's going to give you multiple ways to execute or to kind of solve the same problems. What's important to take away from what we went through today are things like the objects being passed by reference, which is oftentimes a sticking point, and extending things when you need new objects and stuff like that. Anyone else have anything more? You have any questions? No. No questions. Glad we could answer all your questions preemptively. Does anyone else have anything to say? I think that might be it. I can get to eat a sandwich. All right. Well, thanks for sticking around this week for Hashrocket Book Club. Join us next week for, watch the Hashrocket Twitter, but it's going to be the rest of this chapter and some portion of chapter 6, probably, although the rest of this chapter is pretty long. So,
Definitely chapter 5.
At least chapter 5 next week. Thanks for watching.